Okay, so following on from definite integration, we use it to find the area under a curve. We're going to just jump straight in. Again, this one shouldn't take too long, but we'll see. Questions will look something like this. Find the area of the finite region between the curve with equation y equals 20 minus x squared and the x-axis. So the graph is going to look something like, it's a quadratic and it is sad because it's negative, which is if you are negative, then you possibly are quite sad. Yeah, it's a sad face because it's a negative graph. Why have I never made that link before? Anyway, so we are finding this area in here. So between the curve and the x-axis. The first thing we need to do, though, is find the limits of the integral. So we're integrating between these 2 points. So we need to find where our quadratic is crossing the x-axis. So we need to find the roots. So I'm going to put 20 minus x squared equal to 0. I'm going to swap everything to the other side because I don't really want to have a negative x squared. So I'm going to get x squared plus x minus 20 is equal to 0, which when we factorize gives us x plus 5x minus 4 is equal to 0. So it's crossing the x-axis at minus 5 and 4. So this is minus 5, this is 4. So they're going to be the limits on our integral. So we integrate the original equation between 4 and minus 5. And we're doing minus 20 minus x squared dx. That gives us 20x minus x squared over 2 minus x cubed over 3. We don't need the plus c, and we are then going to evaluate that between these two values. So do it one by one. Probably going to have to do it on, I'm going to do a new line so that I have enough room. So my first bracket is putting 4 in for x. So I have 80 minus 16 over 2 minus 64. Yep, 64 over 3. And I'm going to subtract minus 100 minus 25 over 2 plus 125 over 3, because negative 5 cubed would be negative 125. Negative makes a positive. So what do I get? 80 minus 8 minus 64 over 3 is 152 over 3 minus negative 100 minus 25 over 2 plus 125 over 3 is minus 425 over 6. So I have 152 over 3. Oh, didn't want to do that. 152 over 3 plus 425 over 6. 243, yeah, over 2 is the area underneath that curve, between the curve and the x-axis. Yeah, 243 over 2. That's it. I mean, this is the most basic type of question that you could be asked in terms of finding an area under a curve, but that's it. If you're not already given it, or it's not already obvious from the diagram, they'll often give you the diagram with the roots kind of labelled. But if they don't, find the roots, integrate the equation of the curve between those two limits, and then evaluate it. Done. Easy. We'll do one more example And again, yeah, this should be quite a short video. So this is a part C of an exam question, and you've got the finite region R as shown in figure 2 is bounded by the x-axis and the curve with equation y equals 27 minus 2x minus 9 root x minus 16 over x squared. X is greater than 0. The curve crosses the x-axis at the points 1, 0 and 4, 0. Use integration to find the exact value for the area of R. So, easily done. We are going to integrate between 4 and 1 the equation 27 minus 2x minus 9x to the power of a half. I'm changing them to power of x's as I go. Minus 16x to the power of negative 2 dx. Okay, and now I'm going to integrate it. So that gives me 27x x squared divided by 2 means just minus x. I get x to the power of 3 over 2. 9 divided by 3 over 2 is 6. That becomes minus 6. And then I've got x to the power of negative 1. Increasing the power, and yeah, negative 1 divided by negative 1 gives me positive 16. And I'm then going to evaluate that between 4 and 1. Substitute in 4 into the equation, into the expression, and then substitute in 1. So I get 27 times by 4 is 108 minus 16 minus 8, 48. Doubting myself. My head hurts. Such a headache. 3 over 2. 48. Plus x4 to the power of minus 1 would be 1 over 4, so it would be 4. And then I minus in, I'm going to do it underneath. 27 minus 1 minus 6 plus 16. Oh, that was easy. 108 minus 16 minus 48 plus 4 is equal to 48 minus 27 minus 1 minus 6 plus 16, 36, gives me 12, which I know from checking before I started that is the correct answer. And again, that's it. That's all we had to do. That one was, the integration was more difficult because of the negatives and the fractions and stuff. But they gave us the roots, so we didn't have to do that. Quite a nice question. If you could get a 6-mark question like that on an exam paper, you'd be winning. Yeah, that's a lot of marks for a pretty straightforward question. But yeah, that's it. That's area under a curve. When it's bounded by the x-axis, it becomes a little bit more difficult if it's the area between a curve and a line or between two curves, but that's area between the x-axis and a curve. Lovely, nice and easy. The next video we're going to look at will have where we've got some negative areas as well and how we deal with that. But for now, that's it. Hope it made sense. Hope you understood. Thanks for watching. I'm glad this was another short one. I'm getting better at keeping them short and sweet. But yeah, thanks for watching and listening. Have a lovely day.